Apache Hadoop, which was released in the year 2006, was considered a revolutionary big data technology, and Hadoop's adoption continued to increase for years after its release. Several big tech companies made Hadoop as their primary choice for big data processing. But something happened to Hadoop around the time in the year 2014 when Spark started gaining its popularity. And Hadoop's popularity started to decline. And that brings up a very important question. Why Hadoop lost its popularity? I mean, Hadoop was very widely adopted by the whole world and by the tech giants. What happened suddenly to Hadoop after Spark was launched and Spark gained its popularity rather? That Hadoop lost its popularity. And this is what I'm going to focus on. Hadoop's key 3 drawbacks which made it lose its popularity. And we'll also look at what all Spark offered and how Spark overcame those drawbacks. First, Hadoop's MapReduce programming model. MapReduce was still simple to express useful programs in, but still was not too simple. Well, this is a broad statement. Let's look at it with an example. So what we want to achieve here is, we have this input data with some words in it, and all we want is that word and the count of that word in this input data. Such as ball. If we focus on this, ball occurs twice. So what we want as the output is ball with 2. Similarly, cat 3, dog 2, pencil 2. We'll look at it using MapReduce. Now to solve this such a simple problem, what MapReduce required you to do was, you have to first split your data into splits, such as these 3 splits. Then you had to go through a map phase, which required you to convert your data into key values, and that was a prerequisite. Meaning here, dog 1, ball 1, pencil 1, dog is the key and 1 is value. Then it had to go through a shuffling phase. And then there was this reduce phase, which used to count the number of occurrences for each key. And then the final result was produced. Now, this wasn't the best solution. Let's understand it. Why? If for our world retailer, if they want to understand, okay, for their customer residing in Texas state, which are the 3 nearest store of that customer? For this, what they needed to do is to write a MapReduce program, because Hadoop required you to convert problem into MapReduce. So for this simple problem, what it required was to write a mapper and a reducer, and inside each you would have to have a map and reduce functions. Well, I'm not saying that every problem required you to write a reducer as well. I myself have written map only programs as well. But converting every problem into MapReduce was a bit cumbersome, and it became a bottleneck for several organizations at some point of time. On the other hand, Spark's programming model and easy to use API provided us an easy way of solving this same problem of finding the 3 nearest stores for every customer. Using which we can just create a Spark session object, which is the entry point for every Spark application. And we can just create the data frames for customers and the stores. Just use the same Haversign formula, which is a generic Haversign formula logic, which we can use. And we just need to write simple code to find the distance for each store from the customer and find the 3 nearest store for every customer. We didn't have to go through that cumbersome process, which became a really big headache of converting every problem solution into MapReduce logic. Spark completely relieved us from that. Second drawback, Hadoop's disk-based operations. Hadoop used MapReduce, and MapReduce transient data was always stored on local disk. So its programming model didn't utilize memory very efficiently. Instead, the operations were more of disk-based. Let's understand this statement. MapReduce used to read the data from input data file, and the intermediate data it used to write back to the disk. Then the successive MapReduce used to read back the data from disk and in turn write the data back to disk. And then successive MapReduce job used to read the data from disk, and then the final data was written output. And these disk-based operations became a bottleneck at one point. and people started thinking twice before starting to use Hadoop. Whereas when it came to Spark, Spark leveraged memory. So it read the input data and wrote the intermediate data in memory instead of disk. The successive Spark job read the data from memory and wrote the data back into memory. Then Spark job would read the data from memory and finally wrote the output data. This utilization of memory was very efficient. And if we take a look at Spark API, we have a cache function using which you can directly persist the data into memory. This efficient utilization of memory, which was inherently and automatically done by Spark, made it extremely popular. In addition, it also offered us so many functions as part of Spark library for us to save the data into memory and in turn fetch the data from memory. This was revolutionary, and this factor itself overcame all those slow disk-based operation challenges which Hadoop brought in front of us through its MapReduce programming model. So Spark came out as a superhero with efficient memory utilization as one of its superpower. Third drawback: machine learning and graph processing. These two areas were the ones which Hadoop was not best suitable for. So MapReduce paradigm makes repeated querying of dataset very difficult. It was just the way it was designed. And machine learning requires multiple processes through a dataset. Similarly, in graph, there are some iterative algorithms which have to revisit a single working set repeatedly several times. So machine learning and graph processing were the two areas which Hadoop was not the best candidate for. On the other hand, Spark offered mlib. Mlib is Spark's scalable machine learning library. And this was 100 times faster than MapReduce. And Spark excelled at iterative computation, which was a weakness of Hadoop. In fact, a logistic regression performance benchmark was done between Hadoop and Spark. And Spark took almost 100 times lesser time than Hadoop. Graph analytics. Spark offers GraphX, which is Spark's API for graphs and any kind of graphical computation you want to do. Basically, using GraphX, you can run different graph algorithms such as PageRank, connected component, motive finding. Just listing few out of all, there are several other algorithms you can use, and you can achieve graphical computation on your data in a very fast and distributed way. In fact, in a performance benchmark through PageRank algorithm on a 3.7 billion edges graph where 20 iterations were done, GraphX took the least amount of time when compared with other graph processing systems. Besides GraphX, Spark also offers another graph processing solution, which is Graph Frames, which is a data frame based graphical solution and which is also very optimized. So Hadoop, which was a giant elephant which captured the whole market at one point, started losing its popularity, and that was primarily due to slow performance.